today. Hopefully the test went great and it's great to see you. We're gonna get started with Unit 6. So we're gonna jump into the Unit 6. It's called stoichiometry. But before we do anything else, I want you to get onto your computer and open up the slides for today. Okay, so you have to go to Google Sites, go to the weekly calendar, and click on the slides. So I'm gonna be going through the slides with you, but it's nice for you to have them up as well. Okay, so the warm-up question today is, how many eggs are in a dozen? Okay, if I ask you that, you think about it, oh gosh, you go to your fridge, you pull it out, you count how many there are. There are, in a dozen equals 12, okay, 12. And if I ask you, how many blueberries are in a dozen? You say, oh, there's 12 blueberries also. So a dozen means 12 things. 12 of anything. It could be anything. I say a dozen ducks, a dozen bagels. It's a 12 of everything, right? So the word dozen means 12 things. And you're thinking, Mr. Talley, where are we going with this? It's going to make a whole heck of a lot of sense in a moment. Okay, so today if you look at the agenda, we're just looking at the holy moly notes. Okay, and so we're going to look at what is a mole and what does that have to do with chemistry at all. Okay, so you also have linked in Google Classroom, in Google Sites, on the weekly calendar, a link to toolbox terms. Okay, and that's going to be one of your assignments for this week. So you want to make sure you have that out and you're filling that out as well, and you'll be submitting that on Google Classroom as well. So as we're going through this, you'll be filling out your toolbox terms. The first term is a mole. Okay? A mole, and it's not the animal that digs around in the dirt. A mole, okay? And if you look right there at the slides, a mole is a unit used to measure the amount of a substance. Very similar to a dozen. A dozen measures that there's 12 things in something. You count up, okay, oh, look like there's a dozen bagels in a dozen of bagels. There's 12 bagels. But with a mole, this is what chemists use to count a number of things. And it's actually a big number because, you know, when you're counting out molecules or atoms or elements, you need to count a lot of them. And so it's also known as Avogadros number, a mole. Okay, I'm gonna write this right here. Avogadros. Oh, whoops, that's not what I used over there. Avogadros number, okay? Avogadro, he's the scientist who came up with it, so he gets his name on there. Avogadro's number, it's not 12 things, ready? It's 6.02 times 10 to the 23 things. Okay? Wow, that is an enormous number, okay? So one mole, if I have 1 mole of things, I have 6.02 times 10 to the 23 things. That's 23 times. You move the decimal place that away. So after the 2, it's 21 zeros after that. So it's a lot of stuff. And we're gonna see, why do we need to know exactly 6.02 times 10 to the 23 of things? Why does that even matter? But it's super awesome, super important. You're gonna love it because chemistry is awesome. Okay, so just to recap so far, 1 dozen things is 12 things. 1 mole of things is 6.02 times 10 to the 23 things. Does that make sense so far? Okay, cool. So, if we have 1 mole of particles, I say, okay, you have 1 mole of particles, that means you have 6.02 times 10 to the 23 particles. Right? If I say you have 1 mole of carbon, you have 6.02 times 10 to the 23 carbon atoms, little carbon atoms. If you have 1 mole of water, you have 6.02 times 10 to the 3 water molecules. Okay? If you have 1 mole of tacos, you got a lot of tacos. You have 6.02 times 10 to the 23 tacos. Okay? Let's do an example. Let me ask you this. If I have 1 mole of avocados, how many avocados do I have? I'll wait for it. Yeah, 6.02 times 10 to the 23 avocados. Okay, so what we're gonna do is we are going to look at the molar mass. Okay, so I'm gonna erase this. You can pause it, you can go back to it, you can reverse or rewind or whatever you call it, TV. Okay, so we're gonna talk about next the molar mass. And you see the word molar in here, that has to do with, okay, moles, okay? So we're gonna look at the mass of a mole of something, okay? How much does a mole of carbon weigh? Let's figure out how do we figure that out? Okay, so the molar mass is the mass of 1 mole of atoms. So I look at how much does 1 mole, or 6.02 times 10 to the 23 number of atoms weigh? What's the mass of it? So the units are going to be, for the molar mass, grams per mole. So what's the mass in grams per 1 mole? And we looked at this in unit conversion in the last unit. Okay, and so you're going to find this number, this grams per mole, on the periodic table. Okay, it's on the periodic table. And so let's do an example. Okay, so here we're going to look at carbon, sodium, and thallium, and we're going to figure out what are their molar masses. All we have to do is look at the periodic table, and you can see the molar mass right below the atomic symbol. That's where it says for carbon, 12.011 grams per mole. Sodium is 22.990 grams per mole. And thallium is 204.38 grams per mole. Awesome! Now we know how to find the molar mass of any element on the periodic table. The next thing I want to do is look at the idea of a representative particle. Okay. Okay, so a representative particle is just what are we representing or describing with this mole? What is this mole made out of? Okay, so if we have like a mole of carbon, the representative particle, what's being represented? It's just an element or atom. Okay, it's one element or atom. What about water? What's the representative particle of water? Is it an element? Is it an atom? No, it is a compound. Or you could say it's a molecule. Right? It's hydrogen and oxygen combined to make water. So it's a compound or a molecule. You can also have another option. That's going to be an ionic compound. Okay, so if you look right here, we have our 3 representative particle types. We have molecules, in this example, a molecule of water. We have atoms, and in this example, an atom of pure copper. And a formula unit of an ionic compound of salt. Okay, make sure while you're listening to this lecture, you're following along with your Unit 6.1 notes, and you're looking at the slides that I have linked for you as well. You can do it. Make good choices.